All right, so in this video, we're going to go through sample question 21 from the Society of Actuaries ExamP list of sample questions. So, upon arriving at a hospital's emergency room, patients are categorized according to their condition, critical, serious, or stable. In the past year, 10% of the emergency room patients were critical, 30% were serious, the rest were stable. 40% of the critical patients died, 10% of the serious patients died, and 1% of the stable patients died. Given that a patient survived, calculate the probability that the patient was categorized as serious upon arrival. So here's what the question's asking. So I'll use SU for survived and SE for serious. Oh God, a lot of things start with S. Okay, so given that a patient survived, calculate the probability that they were serious upon arrival. So, the probability that they were serious, SC, upon arrival, given that they survived. Okay, that's what we're being asked to find. And the information it gives us is whether or not the patient, what condition they were in, as well as whether or not a certain patient died. Now, this is a conditional probability, right? 40% of the critical patients died. Because I'm saying of the critical patients, this would mean that given that a patient was critical, there's a 40% chance they died. So since I'm dealing with conditional probabilities, I'm going to make a table as so. Here will be their condition, C. In this column, I'm going to put the probability that a randomly selected patient is in that condition, either critical, serious, or stable. And then the probability that a patient died. So I'm going to actually change this to the probability of being serious given that they did not die, right? Rather than given that they survived, just for continuity. So the probability that a patient died given that they were in a specific condition of the three potential conditions. So the conditions are obviously your critical, your serious, and your stable. The probability of being in that condition, well, 10% patients were critical, so that's 0.1. 30% were serious, so that's 0.3. And the rest were stable, so that would be 0.6. Let's see, the 40% of the critical patients died. So given that you were a critical patient, the probability that you died was 0.4. The probability, given that you're a serious patient, the probability that you died was 0.1, and then the probability that you died given you were a stable patient is 0.01. And we're looking for the probability that a serious patient did, the probability that somebody was serious given that they did not die. Okay, so that's going to be the probability of being a serious patient, right? And not dying over the probability of simply not dying given you have a randomly selected patient. Okay, now this question is just kind of a little bit trickier than some of the previous ones if you've been kind of going in order of these kind of questions on the sample list. Okay, so we are not actually given the probability of dying, the probability of surviving. We're given the probability of dying given that you're in a certain state. Okay, so we can figure out the probability of not dying of surviving given a certain condition. Because, for example, if out of all these patients, 0.4 of the critical patients died, that would mean 0.6 of the critical patients survived. All right, hopefully that makes sense, right? If 0.1 of the serious patients died, that means 0.09 of the serious patients survived. And then if 0.01 of the stable patients died, that means 0.99 of the stable patients survived. So now that we have this column, we can go into Bayes' theorem, right? And again, right now, as of filming, I don't have a video on that. However, if you want a video on that, just leave that in the comments. And if I eventually make one, I'll make sure to link it if possible. You can search for it on my channel. So the Bayes' theorem would say I need to know the probability that a patient is serious multiplied by the probability that they survived given that they were in a serious condition, divided by the probability of being in a serious condition times the probability that they survived given they were in a serious condition, plus the probability that they were in a critical condition times the probability that they were in a critical condition given they times the probability that they survived given they were in a critical condition, plus the probability of being in a stable condition times, and I'll just write it down here because I ran out of room, times the probability that they survived given they were in a stable condition. All right, so that's just setting up a Bayes' theorem problem. I can't stress this enough. This is very basic. It's super important to know this. This is like, first week of a probability course in like undergraduate, So, so filling in this information, right? I can actually just write one more line. Probability of being serious, that's 0.3, times the probability that you survived given that you're serious, that's 0.9, divided by this information, 0.3 times 0.9, keep making that mistake if I go kind of too quickly, times the probability that you're critical, so that's 0.1, times the probability of surviving given that you're critical, so that's 0.6, multiplied by the probability, adding to that, the probability that you were stable, so that's 0.6, times the probability of surviving given that you're stable is 0.99. And this I'll just put into my calculator real quick. So the numerator is 0.03, sorry, not 0.03, is 0.3 times 0.9. Denominator is going to be 0.3 times 0.9 plus 0.1 times 0.6 plus 0.6 times 0.99. Okay, and that gets me the following answer. I'm going to just kind of running out of room, so I'll write it here. Following answer of 0.292207792. That's what my calculator is displaying. However, here we're rounding to 2 decimal places. That's what the answer choice is in. So that's approximately 0.09. Answer choice B. Okay, so what can we learn from this problem? 2 major takeaways. 1, Bayes' theorem is super important. I say that a lot because it's very true, and just understand it. Bayes' theorem, knowing how to do it inside and out, super important. And the other thing that's important is how easy visuals make a problem, right? If you've seen some of the earlier videos I have, I'm constantly just, all right, what's the information we have? How can we throw it into a chart or a diagram or a picture? Because that's such an efficient way of categorizing information. Okay, and I just kind of make these columns. And then you should also be familiar with the concept of if you have two events, right? If you have A, the probability of A plus the probability of the complement of A, right? A plus not A, that should equal 1. That's how I kind of got these values. 1 minus this value gets me this value. If there are any questions, leave down in the comments. If there's anything you want me to clarify, I'll do so to the best of my abilities. And if you want to see more questions like this done out, I have a playlist. Click the playlist, go through some of those. And if this video helped you out, hit the like button, subscribe. That definitely helps me out. Okay? Other than that, good luck, guys.